Okay, Hoverball part 2, actually the hoverball is turned off now, all right? So in order to move it at a constant speed, I'm still gonna have the weight and the table, okay? I'm assuming it's going this way, right? If I push it this time, okay, and there's friction, right? I have to push hard enough to overcome the friction at an equal amount. All right, to keep it moving at a constant speed, I have to balance out however much the friction is pushing, okay? After the push, all right, the only thing that's different, right, the table and the earth are interacting the same, okay? The friction is interacting the same because it's still moving, right? It doesn't matter what else happens. That's an interaction between the table, okay? If it's still moving, that's the same, but now, all right, there's no other force in the positive direction because I'm no longer pushing it. Okay, that's going to make the forces unbalanced, right, which will slow it down. So eventually it's just going to come to rest. No hands. And then once it stops, right, if it stops and no one's trying to push it, then no friction either, right? So the forces in the first case are balanced as it moves at a constant speed, and I have to push enough to balance the friction. Then the forces are unbalanced, okay, as it's slowing down. All right, the velocity is this way, but the acceleration is this way because we know it's getting slower. Okay, and then once it's stopped, the forces are balanced again. It's at rest. Okay, so this one's going to look sort of like constant speed, slows down, then comes to rest. Okay, all right. So the important part here, balanced forces keep the motion the same. Unbalanced forces change the motion. All right, that is it.